Hello and welcome to Physics Ka Doctor. My name is Dr. Kanshyam Tejani and let's start. Class 11, Chapter number 3, Motion in Straight Line. The similar topic is also covered in the JEE as well as NEET, Unit number 2, Kinematics. This is session number 4. In this session, we will be considering motion under gravity. Motion under gravity. During session number 1, we studied distance and displacement, its differences, as well as we had taken so many examples from NEET, JEE, and all kinds of examples that can be asked during exam. In the session number 2, we studied speed and velocity. Difference between speed and velocity, as well as with so many examples were solved. In the session number 3, we have taken motion under horizontal line, which are one dimensional movement without considering gravity. Also, we had one example of gravity, but that was discussed. And in this case, this session, we will be talking about motion under gravity. How it works. Let's see. So, first, that is a motion under gravity. When we consider motion under gravity, any object, say for example, object is here, ball. And when we release the ball, what happens? The ball moves towards Earth. This is Earth. This is our Mother Earth. It moves towards Earth, and because of what? Because of gravitational force. The force by Earth. And initial velocity of this ball, let us assume u, when we release this ball, so is 0. And when then it strike and dig the ground, at that time velocity is v. So we know that v is always greater than u when the ball moves in a downward direction. Because of what? Because of gravity. Because of gravity. And here ball accelerates, because we know that acceleration is equal to change of velocity divided by total time, and therefore gravity is adding value, and therefore gravity is to be considered positive. Remember, when we consider movement of any free falling object, its gravity is to be considered positive. Understand? Let's have similar example. This is our Earth, and we have a ball. Now ball is thrown in the upper direction. Ball is thrown in upper direction. So initially it is having some velocity. When it moves on the upper direction, and after some time velocity, say for example v. Right? So we know that because of this gravitational force by the Earth, what happens? It always attract body towards Earth, and because of that, there is a reduction in velocity, and therefore final velocity is always less than initial velocity when ball moves upward direction. And because of what? Because of gravity is pulling the ball down, and therefore its effect is negative. It is reducing velocity, therefore acceleration is to be considered negative. So here what you remember, just remember two things. When ball moves the downward direction, g, acceleration become negative. Wrong. Acceleration is positive. And when the ball moves in upward direction, acceleration become negative. Just this much you just need to remember. No other part is required to remember. Now, for the equation mathematical part, let us consider the motion of a body with uniform acceleration g, right? And we can have initial velocity when the body is moving from one place u to another position v, to the another position v, right? And the time taken for change of velocity from u to v, that is considered t. Now see, we already proved equation for uniform acceleration. You just need to put in place of g in place of a, or you can keep this equation as it is, do not change anything, and whenever it is required you just use a is equal to g plus or g minus. Do not remember this equation again and again, it is not required. Then we know that average velocity equation we already have this equation, put the values in the above equation, so you will have another answer. So this is equation number 2. Here you can use a is equal to g, maybe positive or negative depending on its direction. And this from the equation 1 you put this value, you will have another equation like that. This is equation number 3. Remember again equation, but a can be positive g or negative g. Do not remember equation, a separate equation, by considering here changing g when it moving upward, or it is not required at all. This equation will be useful, right, for all the cases. Do not remember extra equations if it is not required, because it will add your memory and you will have a more confusion. With the increase of difficulty level, equation will be large in number and this may create a big problem. So let's understand the topic by solving different questions, and this is going to be a best method for us. So what is to be given? It is given a particle is projected vertically upwards from the ground with an initial velocity u meter per second. It is given like that. This is somewhat particle. It is starting from the ground position and it is moving upward direction, and the initial velocity it is u. Initial velocity is u is equal to u meter per second. So now what we need to find? First find the time taken to reach maximum height. So you can take example when the ball is thrown in this direction, and we know that at certain height it reaches and then it returns. When it this reaches at a maximum height, so right, it is having velocity 0. It is having velocity 0. And the time we need to find here, time required to reach velocity at the top portion. So that is one. Second is the maximum height reaches. Right. To become velocity 0, what is maximum height? That we need this too. Then time required for descending means it is a reverse process. Returning, when this ball returning, say for example ball is returning down, going down, and it dig or strike on the ground, and at that time it is having initial velocity u. For the second condition u is equal to 0, and here it is v. What we need to find? We need to find here time required for the returning journey and velocity. When it strike the ground we need to have velocity. Oh, this many things are required. Great. So equations given by God, we need to remember this. Do not remember equation with g. The both will be same. When the first case we are considering here, object is moving, this is the considering object is moving upward, so acceleration is equal to minus g. We have to consider minus g for the upward movement. Let us find first t. We have equation for that. Final is 0, initial is u, acceleration is minus g, put the minus g here, and t is equal to u g. So this is our first solution. T is equal to u by g. Second, to find height, to get height we need v square minus u square is equal to 2as. Final is 0, u is u, upward movement g, and h is equal to u square by 2g. H is equal to u square by 2g. So you may remember this equation also, equation number 2, when body is moving or when it reaches to top height, what is the equation? H is equal to u square by 2g. Then next is the body is now returning. What happened to that? When the body is moving downward direction, acceleration become positive g. So initial velocity is u, and if we need a time, what is the time is required? So t, and returning a is equal to g. So is final velocity given? No, fine. Initial given, yes. Acceleration, yes, given it is g. The time required that we need to find. So we can find this value is equal to u by g, u by g. And initial velocity is always similar. Let's prove also. Right. So we got s and h we need to find out here. Let's erase this stuff. Then the last velocity when it strike the ground, so let's is equal to v square minus u is equal to 2as. Equation we can take here. So when object starts from the top position, initial u is 0, it strike on the ground, v is equal to what? We assume as a v is equal to v2, but what? That is our requirement, right? And acceleration is equal to positive g. We put here final v2 minus g. We can put here, and that is the equation. V square is equal to u square, because u is equal to, we already have equation, u is equal to that equation. We can put the equation, g is cancelled, and v square is equal to u square, right? So initial velocity, if you hear, so whatever initial velocity of the object under free movement, the returning velocity, this is the final velocity of second position, that u become v, as well as whatever time is taken during upward movement, the similar time it is to be taken by the returning movement, and also height is taken during movement upward and downward is also similar. There is no change. So these things are, you have to remember. You can directly find also this, right? No need to have a calculation, but we can do it like that. So that is the question. Simple, very simple question, fundamental question to just understand these equations. Now question number 2, it is like that. A small steel ball is shot vertically upward from the top of a building. Let us assume a building having 25-meter height, and from this position, a steel ball is shot vertically upward from the top of the building, right? And the initial velocity is given, u is equal to 18 meter per second. It reaches to top position and return and strike on the ground. Fine. So what do we need? In what time will it reach to maximum height? So we need here when it reaches to maximum point, when it reaches to here maximum point, so what become? Velocity becomes 0, and we just need to have time for this case. So this is first we required. Second is how high the above building will be ball the rise. So from this distance we require as, we need this distance as, fine, it is very easy. And then compute the velocity with which it will strike the ground. That means at what time, when it travels the full, at what time, say for example v2, it strike the ground and dig the ground, as well as total time total, right? So what is the total time is taken for the full journey of the ball, steel ball? What is time taken? That is required. Wow, great. So see, first is the most important part is we need to have a figure. Let me again explain the same figure. A small steel ball shot vertically upward from the top of the building. So this is the building. This is the building. A person is here somewhere. It is shooting a ball. Ball is moving upward, and this is initial velocity u. When it reaches to top, this becomes final velocity v, and velocity is 0. And for this condition, we need time. as well as height to be turned. So this is 1, this is 2. Second, when this ball strike the ground, so we need velocity at ground and total time taken during flight. That is the requirement. So we have first, let us find first time and height. Let us find time and height. So first we have here u. We in the equation have u. We have three gods given equations we can find out. And when the body is moving initially, acceleration become negative g for the initial condition moving upward. So initial velocity is given, yes. Final velocity is given, yes. Can we find t? Acceleration is also given, yes. So we can find t, as well as we can find how high the above the building ball will rise. That is also the case. So this equation, first equation is given by God. We can use this equation, put the values here, and time is become 1.8 second. So ball starts from top of the building, reaches to its maximum height, and it is taking t is equal to 1.8 second. Now this much time is taken. Second is that how high above the building the ball goes. So h, we need h here, h. So similar data, we need h, but that means s become s is equal to h, s is equal to h. Initial velocity given, yes sir. Time is given, no sir. Acceleration is given, yes sir. Time is given, no sir. Oh, equation, can we use this equation? No. Then equation number 3, v square given, yes sir. Initial velocity given, yes. Acceleration given, yeah. Then use this equation, use that. Equation is here for us. Put the values here. V is 18, u that becomes 0. As put the answer is equal to here. Opposite values are taken. Don't worry. So height is taken 16.2 meter. So that h ball is rising from this point. It is 16. Great. Point 2 meter. Now considering a next case where ball is moving down from the top position, that will acceleration is to be considered minus g. So total distance that is to be travel, if we are taking distance from this position, right? So h plus 25, h we already identified, so become 41.2, and total time required for this journey we can identify from that. Equation is same, right? How to identify equation? I don't think it is required now. Initial velocity and final velocity. You are wrong. V is final velocity. U is initial velocity. Initial becomes 0. Distance is traveling h plus 25. Put the values here. Not visible, sir. You can see now. Is it visible? Yes. So V2 and V2 become 27.7 meter per second. It strike the ground 27.7. You can cross check also. That value should be greater than 18 meter per second, because here if it is reaching at exact the same position, so it become 118 meter per second. But again it is further increasing speed because it has acceleration and it is increasing its nature. Great. The last portion we need time. So use this equation for the time. Put this value here, and this is t2, means from the top to bottom time is required, and it is 2.77, and total time required, a ball is moving upward, and time required, ball is moving downward. Upward time is 1.8 second, ball is descending, it is 2.77, total become 4.57 second. So in this manner we can solve example. You must be getting some kind of feeling with the physics. Great. Let's solve another question. Question number 3. From the top of a building, it looks like a similar question. Pause the video and solve the question. Unsolved question, it always increases confidence, and a correct answer brings joy. So what is mentioned here, from a top of a building, let us have a building here, distance is 40-meter tall. A ball thrown vertically upward, let's have another color ball. A ball is thrown vertically upward with a velocity, initial velocity is given 10 meter per second. So question is asked, after how long will the ball take to pass through the point where it was projected? So it was ball is projected, reaching to maximum position at v is equal to 0, and again it reaches to its original position here, right? So we need to find time required for this full journey, right? Time required for that full journey, and here your final velocity become 10 meter per second, and the time required, say for example, if it is t1 and if it is t2, both must be equal. This thing we need to find out. So if we identify, just find t1, then we can get total journey time. Second is asked, let's have another color. After how long will the ball hit the ground? Oh, ground, it now strike the ground. So we need to have total time for that. Total time. So here T1 plus T2, maybe you can find out time required for this journey T3, right? And we thought velocity is required here, grand, 2. So let's solve it. Let's solve it. When the body moves in upward direction, your acceleration become minus g. And during your NEET examination, as well as JEE, you should take 10 because you don't have a calculator over there. Let us understand the similar question once again. What is given? A building is given. This is a building is given 40-meter height. And from here, someone is throwing from the top of the building a stone upward direction. Initial velocity, that means u, 10 meter per second. It reaches to top position. Return to here, and we need time for the t1 plus t2. We need this time. Both are equal, so become 2t. As well as we need total time. So here time, and as well as v2, we need this much time. So during upward movement, acceleration become g negative. Good. Which equation is used? V, final velocity, yes, it becomes 0. Initial velocity, yes, it is 10. Acceleration, yes, minus g, and the time required, yes. Let's find out this. This can be useful. So time required for the upward movement is 1 second. So we know that t1 is equal to t2. So to return journey, when it reaches to return position, it is double. Time is double. When it reaches to this position, time is double. Great job, great job, great job. Let's move. Oh, time is 2 second. 2 multiplied by 2 second. Great. Now, from this position, let's calculate further. If it is moving downward direction, so whatever acceleration is positive, and we know that if you are calculating from this position, so initial u, that must be here velocity 10. There is no change in this case, right? At the same time, velocity is the similar, right? At the same distance, similar distance, velocity is the similar. Ball is moving like that, touching position, and at every height, the velocity is similar, right? So v is 10, we can take, and let us take distance 40. Distance is 40. So v2 we can take, distance is 40. Time only t2, we are considering this much time. Use this equation, s is equal to ut plus 1 half 80 square. Put value as 40, 10, and t. And the equation, t is 4 or t is minus 2. Minus 2 is not possible, so time required for Here we need a total time, we need a total time, we need a total time. So total time become t plus t2 is equal to 6 seconds. This will take 6 seconds. Now, in the question number C, we need to find velocity v2. So we have equation for velocity. Let's use this equation. V square minus u square is equal to 2s. Put these values here and v is equal to 30 meter per second. Right. So see, this problem can be solved by multiple methods. You can consider direct position first, initial steps directly from this entire journey can be calculated. You can take position from the top and this distance or time can be calculated, or it can be considered from the midway from here, right? So this, when it start, we will calculate in the next example. We already calculated from the top when it reaches. We already calculated now how from this middle position, and now we will calculate from the top. So all the method you should know. Hey, no one know, right, during examination which method is applicable directly to you. Let us have one more question. Question number 4. If a stone falls past a window of 2.45 meter height in half a second. Suppose this is a window, you live in a flat or somewhere, and this is the height of window is given 2.45 meter, and you are somewhere sitting in the your drawing hall, fine, you are here somewhere watching TV, and suddenly some stone is moving from the top and it reaches here, so it is visible during window and it moves in the downward direction, right? So you notice that this time taken by this stone which is visible during window from top position of window to the bottom position of window, this is taking 0.5 second, as it is mentioned half a second time, right? And you want to identify the stone is coming from which height. It is asked, see, high, find height from which the stone fell. I remember a Kapil Sharma's movie in which Kacha, right, moved from the top to the some position, and you can identify from which floor Kacha moved, right? Because she understands science in that character, Johnny Lever's daughter. And yeah, if that was the truth, then she can identify from which floor that came. Anyway, jokes apart, it was that. So we need to identify this one. So we should understand this question thoroughly, and graphical representation is very much important, right? So let us assume here this is our building height from where the stone is falling, h, and from the window, top of the window, this is now visible, and this is window height. When this stone falls from A to B, it is not visible, but B to C it is visible. The window height is 2.45 and you are sitting somewhere here, and you observe that from B to C it is taking 0.5 second time. That is the required, right? So let's solve this example, let's solve this equation, right? Equations given by God, we need to remember, and the stone is falling downward. It means what is the acceleration? G. Oh, great. Correct. So we have here, when the stone is moving from this position, started somewhere from initial acceleration u is equal to g, u is equal to 0, and let us just first calculate distance from A to B. Let us just calculate from position A to B. A is u is equal to 0, and when it reaches to here, we don't know velocity, but it is taking height h. It is taking height and falling with gravity g. So s is equal to h, and equation we have s is equal to ut plus 1 half at square. Initial is 0, a become A become what? A become what? A become G, and T we don't know. Fine. So we can have H is equal to 0, 1 of GT square, and we can have this is the equation number 1. This is the equation number 1. What the reference? We just need reference. Then let us consider returning journey from A to C. Right. Ball is moving from straight away from A to C position here, and therefore total height is equal to H plus 2.45. Ball starts from point A, reaching point C. A to B is H and B to C is 2.45. So total height becomes this. And velocity becomes somewhat like that. Put the values here. S is equal to U, initial is 0. A is equal to G and T don't know. So H plus 2.45, 1 of G, and T we know that T. From H, this it is taking T, it is taking 0.5. So we know that T plus 0.5 T, that become total time. Total time, that is the total time of travel. Let's solve equation number 1 and 2. Equation number 1 and 2. We just 2 minus 1. So this is to be cancelled. H is to be cancelled. Become 2.45 is equal to G, and G is 10. So T is equal to 0.2495. You can take also 0.25. That is sufficient. 2 digit is sufficient for your answer. And that's the solution. What we need here, from what height we require. So put the value of T in that equation and you find height. Comment height in the comment section. What height you got? So let's solve question number 5. A person sitting in the ground floor of a building noticed through the window of height 1.5. The similar question. You solve this question by yourself. Pause the video here, solve the question, and you just verify the answer. Yes, you should verify the answer. Let's have solution. A person sitting in the ground floor of a building notices through the window, similar window we have here, and window height is given 1.5. A ball dropped from the roof of the building crosses the window 0.1 second. So let's have, it is window is given 1.5 second and it is taking time to cross this window 0.1 second. If you are directly starting with question number 5, so I simply suggest that you go back to question number 4 where detailed explanation is given. So what is velocity of the ball when it is at the topmost point of the window? That means here initial velocity we need U is equal to what is the velocity, and G we need to take 10. And when object moves from top to bottom is downward direction, G is always positive. That question was asked in NEET 2020. Great job. And the options are also given. Wow. Let's solve it. Equations given from the universal God. It is like that. And when it is movement is downward, we know acceleration is G. Right. And initial velocity, let us assume U. Distance is traveling 1.5 and T is here. And what we need here, total height we need. So let's put this in this equation. S is given 1.5. U initial velocity, it is not given. Find time required to cover this window displace. It is given 0.1. Acceleration is given 10. Yeah, the same equation should be there. Put this values here. S is 1.5. U is required to find. Time is given. A is 10. T is 1. So we'll have equation like that, and the answer is 14.5 meter per second. 14.5 meter per second. What is us? The velocity of ball when it is the topmost point. We need velocity here. at what ball reaches. So let's have 14.5. It is the answer when it reaches to top of the ball. You can find also at what velocity it strike at point C. Also, you calculate what is the velocity when it reaches to point C, means bottom of the window, and put on the comment section. See, different options we need to find out, and NEET and JEE, they used to play with this only, right? You just solve a single one example like that. You solve all the possibilities. We always need to solve all the possibilities in which question can be asked. So you can have a better option for that. And you can have a speedy option also. Next question, question number 6. A ball is dropped from the top of the tower. Again, question of tower. 30-meter high tower. That is to a tower. This is a tower, right, from which a ball is dropped. The height is 30 meter from the ground. Great. At the same instant, a second ball, another ball is thrown. Let's change color. At the same instant, second ball is thrown vertically. Let's give name of this ball A. This ball is B. Upward from the ground with an initial velocity u is given here 15 meter per second. And for that, so it is not given any velocity, so you can have 0 meter per second. And question is asked when this ball is moving in downward direction, when they cross, right? So at what distance that is to be crossed. Say for example, height from the ground. So at what distance they will cross, and that distance becomes 30 minus h. Right. So this question is asked like that. Let us understand the same question once again. A ball is dropped from the top of the tower. So this is the top of the tower. This ball number A, and the height of the tower is given 30 meter. At the same instant, another ball, say for example B, it is moving upward, and initial speed is given u is equal to 10 meter per second, not square second. And height, let us assume height from the ground edge of ball 2, and therefore from ball 1 that becomes 30 minus edge. And at when and where, the distance and time both we require to identify. Great job. We have equation of God. So two balls crosses is there. Let's assume h is height and time is t. Whatever time is taken from the ball 1, that must be equal to ball 2. Both are taking similar time because both are dropped at the same time. When acceleration, when the ball is moving up, acceleration is equal to minus g, and when ball is moving downward direction become plus g. That we know it very well. And that, let us calculate for the ball A. For the ball A, for the ball A, ball is moving downward direction, acceleration is plus g. Initial is 0, right? And distance is traveling s is equal to 30 minus h. Wow, 30 minus h. So we need this equation as is equal to ut plus 1 of at square. Put the values here. S is equal to 30 minus h for the ball 1. This is for the ball 1. U initially it has no velocity, so it becomes 0. Acceleration is down direction, so g. So you can put here equation number 1, 30 minus h is equal to 1 of tan t square. Great, great, great. Very simple. And second ball, this is ball number B, which is moving upward direction. So when ball moves in the upper direction, what happen? Gravitation become minus g. Height taken for that, s is equal to h, and initial velocity is given. It is given not 10, 15. 15 meter per second. So initial velocity u is given 15 meter per second. Similar equation we need here. Again, similar equation, put s is equal to h, initial velocity 15, acceleration negative, and the t. And we have now equation number 1 and 2. Great job. Adding equation number 1 plus 2, so it becomes h minus h plus h is cancelled. Here, the similar term, it is opposite side also, that is going to be cancelled. So 13 is equal to 30 is equal to 15t, and it needs 2 seconds. So both ball crosses after release of 2 seconds. So first answer we got, the first answer. First answer we got. Now we need height. At what level that will is. So put the values of the t in this case equation, and we can get t is h is equal to 10 meter. H is equal to 10 meter. Right. Also, we need to find relative velocity. Oh, there is something new came in the picture. And as well as we need to identify when the velocity a ball, right. So when we talking about relative velocity, let us just find out velocity of ball 1, v is equal to u plus at. So it is 20 meter per second, and the velocity of ball 2, v2 is equal to minus 5 meter per second, minus 5 meter per second, the velocity of the second ball. So let us understand first what is a relative velocity. Suppose you drive a car, or you are in a car A, and your velocity is v, say for example 100 kilometer per hour. And another car, it is somewhere here nearby, and this is a small car which is running at 60 kilometer per hour. And you know that your car is higher, speed is higher, that means you can directly overtake this car. So if you just wanted to find your relative velocity was at what speed you will cross in terms of relative. So what to become 100 minus 60, that become 40 meter per second, the speed, there is a relative velocity in between these two. Similar example, let us understand by using another, so you can have a better idea. Your car is running on a track at 100 kilometer per hour, and another car, it is running, B car is running at 60 kilometer per hour, and you just strike this car, or accident take place. So what is the relative velocity at that time? So it become 100 minus 60. So impact of that load is 60 kilometer per hour, right? So if you run the car and just strike on pole, if you run the car at 60 kilometer per hour and you just have accident, so the impact is equal. So that is the relative velocity. That is the relative velocity, right? So your speed, relative speed with respect to car B, that is become net speed, and therefore VAB is equal to VA minus VB. You are going on the forward direction with respect to car B, that is 40 kilometer per hour. That is 40 kilometer per hour. And on the opposite is true. 60 kilometer car, which is running car number B, that means car number B is losing its velocity. You cannot say losing a velocity, but it is returning, or you can say it is moving back at VB minus VA. That speed means it is having minus 40 speed compared to this car number A, compared to this car number A. So ultimately you don't go in the story, just understand that. If I want to find relative velocity with respect to A, so become VA is equal to its speed, original speed, 100 minus this speed. Say for example 60, so it become 40, that is a net velocity in which you are moving forward compared to B. You can observe similar right like that if driving a car and a person is standing outside, right? Outside. So the speed we observe, suppose your car is 100, so you will observe relative velocity with this person is 100. But another car is driving at maybe 60 kilometer per hour. So we will observe only 40 kilometer per hour speed, and that is the relative velocity. That is a relative velocity. Another example, let us say your car, you are running at 100 kilometer and another car is running at the opposite direction, right, on the opposite side of the road. Your speed is 100 and opposite is having 60 kilometer per hour. So what you need to consider here, your relative velocity become 100 plus 60 because both are in having opposite direction. Both are having opposite direction, that you have to consider. Let us understand this by using another example. Say for example, you are running a car. This is your car running 100 kilometer per hour, and opposite car there is some opposite truck is coming which is running at 60 kilometer. We are not considering mass factor as of now, and you have accident. So at that time, what relative velocity we have to consider? 100 plus 60 is equal to 160. So impact velocity, if you run this car on a road 160 kilometer and strike on some pole, so both impact will be equal, right? Cyrus Mistri's car, your car becomes Cyrus Mistri's car. So that is relative velocity when both are in opposite direction. So AB is equal to VA when we consider direction the negative. So total it become VA plus VB, right? When we don't see direction, so simply VA plus VB. When we see direction, so we have to consider VA minus VB, and the opposite is also true. So like that we can calculate relative velocity. So become here V1 minus V2. The body is moving in upward direction and this body is moving in the downward direction. So ultimate answer, your answer become 25 meter per second. Question number 7, it is very similar to question number 6. I think you should pause the video here and solve this question by yourself. That's all. From the top of the tower, 60-meter tall, a body is thrown vertically down with a velocity 10 meter per second. So tower is somewhere here, and from the top, it is a body is thrown vertically. So it is initial velocity is given 10 meter per second. The tower height is 60, and let us guess body number A. At the same time, another body is thrown at the same time from the ground. Another body is thrown vertically, and the here is body number B, 20 meter per second. After how long two bodies meet? After how long? Somewhere here bodies will be meeting, right? So we need to find time required for that. Both time will be equal. And at what height? We need to find height also. Oh, great. Let's understand the similar question once again. So there is a tower from where ball A it is given. So initial velocity of ball A is given 10 meter per second from the 60-meter height, and the similar time another ball it is thrown upward direction and it is having initial velocity ub. Say for example ball B is equal to 20 meter per second, and at what time this will meet. So we need time required for this travel as well as height. So time is to be equal on both the cases, that we need to remember. Fine. So v is equal to u plus at. Equations are given from the god. Wow. And let's assume that height h from the ground when both the balls are passes, or you can say strike. Fine. So first case, let us consider ball number A, let us consider ball number A, which is moving from the top downward direction. So we know that acceleration is equal to positive g. Initial is given u 10 meter per second and the total distance travel is 60 minus h from this collision to top. Great. Distance we have equation s is equal to ut plus 1 of at square. Put the value of s 60 minus h. Initial is given 10. Time we don't know. Acceleration is equal to 10. Put the values here. Put the values here. Wow. You have a big equation. We can simplify this equation. Right. This is our equation number 1. This is equation number 1. Similar, let's equate for ball number 2, which is moving upward. So therefore, acceleration become negative. When ball moves in the upward direction, acceleration become negative. Initial speed of this ball is given 20 meter per second. So put here 20, not 15, 20. S is h. S is h. S is equal to height. Put values in the above equation. Put values in the above equation. So u is equal to 20, s is equal to h, a is equal to minus 10, t square. Just add 1 plus 2, add 1 plus 2, you can have t is equal to 2 seconds. It is taking 2 second time to contact with each other, to meet, and they can have a story. Second is height, we need to find height, so put this value of 2 in one of the equation, you can find height, h become 20 meter, 20 meter, right? In this case, you can see relative velocity is not asked, but you may find relative velocity by finding velocity of v1 by putting the equation and getting velocity of v2 by that, and the difference will have a relative velocity. What is the relative velocity? That is the difference, like that. So you can solve this. Let's have question number 8. Wow, balloon, new types of data it is there. A balloon is rising vertically upward with a constant velocity. See, remember here, velocity is constant for the balloon at 10 meter per second. Let's draw a balloon. Let's do a balloon is moving somewhere here. It is moving at some constant velocity v 10 meter per second. When it is at height 45, when it is at height 45 meter above the ground, a stone is dropped. Somewhere here, stone is dropped. Stone is dropped. Stone is dropped and it is moving towards ground because of gravity. Right. So if you consider here stone's initial velocity u is equal to 0, then you are wrong. Here balloon is moving upward, that means stone is also moving upward. Therefore, initial velocity of stone, it is not 0, it is 10. And therefore, movement of this stone, it is like that. This is ground, right? So initial velocity of stone, it is 10 meter per second. So what is written? Then stone is dropped from the top. Find the height of the balloon. Find the height of. So balloon is continuously still rising. Balloon is still rising. It is going at some position after this distance. So we first require to time t to reach stone from top to the bottom, right? And the similar time balloon is moving at constant velocity upward direction. It is moving v. So we need to find distance here for that. So let's find time for this. Time for this stone. We know that universal equations are there. And the balloon velocity is 10 meter per second. Height is 45 meter. When the stone is move the ground, find the time. Now see, when we consider this entire movement, right? So initial velocity u is equal to 10 meter per second, and at that time upward movement we need to consider positive, and whatever below that in the downward side, that we need to consider negative. But for the acceleration, of course, acceleration when it is moving up, acceleration is minus g. But the distance is to be considered minus 45. Right? When this is to be considered, when the body is moving up to down, when the total path we are calculating at that time, we need to consider height as a negative for this case. Put this value here. So s is equal to ut plus 1 of 80 square. S is equal to minus 45. S is equal to minus 45. U initial velocity 10. Time we don't know. Acceleration is going up. So minus g minus g, and time we need to find out. Time we need to find. So put this value here. We got equation. T square minus 2t minus 5. T square minus 2t minus 5. So we have to go with this equation. Right. Root we need to find. Remember this equation, and ultimately you just find out solution. You just find out solution. Put the values here, and you will get this two solution. Minus 2.7 and 3.7 seconds. So minus is not possible. Stone is taking 3.7 seconds before it reaches to ground. Let's do again. So we got time, total travel time we got in this equation. Total travel time we got. So here balloon is moving up from the ground. It reaches at certain distance 45 meter and the stone, and from that a stone is fall down. So initial velocity has like that, and then it fall in the down direction like that. So we already got time required for the total. Right. During the same time, during the similar time, this balloon continues to move with velocity, constant velocity v, right, and it reaches somewhat. So we need this time. So we know that constant velocity is equal to distance divided by time. Distance divided by time. S is equal to v by t, and we have solution for that. Velocity is 10, t is 3.7. Answer is 37. Great. So balloon moved up 3.7 second. We know that constant velocity equation is like that, and 37 meter is the answer. 37 meter is the answer. Like that you can solve this example. It's a great question. So height of the balloon, we need total height. So do not make a mistake. 37 will be there in the option, but this is not the correct answer. We need a total height of the balloon, so it is 82. Right? A small detail is to be required to identify. Let's have question number 9, and that is from NEET 2020. We love questions from the NEET. So we can have a feel. Taking examination. What is mentioned? A ball is thrown vertically downward with a velocity 20 meter per second from the top of the tower. Similar question. We already solved this kind of question. A ball is thrown vertically downward. It is thrown vertically downward 20 meter per second. Let's draw at some here a tower. From the top of the tower, the ball is thrown vertically downward with a velocity 20 meter per second. This is A ball downward U 20 meter per second. From the top of the tower, it hits the ground after some time. It hits the ground after some time. It hits the ground after some time. With velocity is given 80 meter per second. The height of the tower, very easy question. Find the height. Find the height. It is very easy. So initial velocity is given, final velocity is given. We just need to have height. Three universal equation. Let's check first equation. U given, yes. Is it given? Yes. A, it is falling in the direction. So A is equal to G. So yes, we can get time t if you use this equation. But we need height, so that equation may not be useful. Let's check second equation. As we need to identify u given, but time is not given. A is given, time is not given. So let's check third equation. V given, u given. Acceleration is not given. Yeah, it is given. And the distance that we need to find. Oh, so that equation is useful. So let's put v square minus u square is equal to 2s. Put the value of v final is 80, u 20, 20, 20, and a it is given 10. Put the values here and you can find solution at 300 meter, right? See, every question is not difficult in NEET and JEE. There are more than 50% questions are going to be like this, right? So be ready for that. Don't worry at all the questions are not difficult. Only around 20 to 25% questions are very tricky. Otherwise 50 questions are normal and 25% questions are easy to solve. Let's solve question number 10. A stone is very favorite here. A stone dropped into a well is hard to strike the water in 4 seconds. Wow, what a sticky question. Say, for example, let's do this is a well and it is having somewhere in here there is some water, right? It is not dry, but it is having some water. A stone is dropped. Let's have a red color stone. A stone, it is thrown from the top, right? So that should be initial velocity is 0, not provide any velocity, and it goes to the bottom. It strike here somewhere, and because of that strike, sound is created. And let's change the color of sound has no color, but let's give some color to the sound is moving up, 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 and we hear somewhere at here, somewhere at. So this returning journey, let's say time is taken t2 and this is t1 and the height of this wall is h. Let's assume this. So what is given? 4 second is given when ball is thrown from the top and it hurt. That means t1 plus t2 is equal to t is equal to 4 seconds. T1 is time required when the ball is thrown in the downward direction. Then it creates some sound and sound is returning on the upward side and we heard the sound. Right? Very easy. Universal equations are here. Use this equation. For the downward movement, we know that acceleration is equal to g for the downward movement of this stone. Start with 0, u is equal to 0, s is equal to height of the well, and let us assume t1 is taken time for that and t2 is. So for the first case, t1 plus t2 is equal to 4 seconds. That is given, right? We already discussed this all. For the downward movement of the stone, we can use distance equation. U initial, is it given? Yes, it is given 0. S is equal to h. Acceleration is 10. T, we don't know. Let's put this value here. We got one equation. We got an equation, right? We got an equation number 1. Now, second is about velocity of sound. So when sound moves, there is no acceleration. It is not having any effect of gravity on the sound. Therefore, it moves uniformly and therefore velocity is become v is equal to total time distance divided by time. The equation is very simple. That you have to remember, right? Do not add g here. Otherwise, your answer will be wrong. So v is equal to s by t and the sound velocity is given 335 meter per second. If it is not given, you remember. And it becomes is equal to 5t1 square divided by t2. We have T1 value here. Do we have value of T1 here? Yes, yes, yes. We have equation number 1. We have equation number 2. And also we have T1 plus T2 is equal to 4 second. Put value of T2 over there, and now equation is having only one value. T1 square plus 67 T1 minus 257. Use this root formula, put the values here, and find the solution. T1 become minus 17.8 or 3.8 seconds. So negative is not possible. Don't be negative. Don't be negative. Don't be negative. Right. And from the equation 1, we have T1 plus T2 is equal to 4 seconds. So can we find? Let's remove this. Let's remove everything. It is not now required. We have equation this either 1 or 2. Put the value of T1 in this equation and we can find depth of well 72.2 meter. So in this method, we can find out depth of well. So different question may be asked. What is time required to pass the sound? That can be one question. Or what is time required to stone reach to the bottom? That can be one question. And the final question can be this. So in the examination, you can have any kind of question by this. Let's have question number 11. Again asked in NEET 2019. A person standing on the floor of an elevator drops a coin. Person is there somewhere here. Let's do. This is an elevator in which person is standing somewhere here. Let us just see. This is a person. I'm not a painter, so I cannot draw, but it look like a person. Fine. And he drop a coin. Drop a coin. 1 rupee coin. Wow, 1 rupee coin dropped here. So initial velocity u is to 0, and it reaches to the floor, right? So the coin reaches the floor in time t1. So it is taking time t1. When elevator is raised, so elevator speed is 0. Elevator is not moving. And the time t2 when elevator is moving, maybe upward or downward direction, it is not mentioned. But when this rupee fall, it is taking time t2 when it is moving upward or downward. So which of the following option is true? Time taken is less, greater, depending upon whether. So you will definitely go with this answer depending upon whether the lift is going up or down. But we need to prove whether this answer is correct or not. Let's see. Universal equations are there, right? At a stationary condition, initial velocity of the coin. In both the cases, it is 0. It is 0. Moving downward, so A become G and taking time T. Right? So distance traveled, it is S is equal to now GT square in the distance. This is H. It is common for both. Right? So we can have T is equal to under root 2S. The ultimately we can write T is directly proportional to 1 by G. 1 by G. Right? When there is a movement. Wow, wow, wow. Great. So we got this is for the stationary condition, that is T1. Great. Now see here another concept we will discuss in the concept, especially when there is a relative velocity. It is considered, and not only just gravity but acceleration to be considered, right? But let me explain the one concept. So this is a lift. When the lift moves in the upper direction, so lift is having some acceleration a, right? And it is also having its effect of gravity, because of gravity pulls down in the downward direction, pulls down in the downward direction. So it is having minus g. When body is moving upward, So resultant acceleration will be its a capacity acceleration minus its a g, right? And when this body is moving in the downward direction, its acceleration, its capacity acceleration plus g, because it is g is supporting. When lift moves upward direction, its acceleration, it is decreasing because of gravitational effect, and acceleration is increasing when this body is moving in downward direction. So total acceleration becomes like that. But here what is mentioned here, special what is mentioned here, see what is mentioned. SL elevator is moving uniformly, elevation is moving uniformly, that means acceleration of this lift is zero. Therefore, in this equation, acceleration is not a picture, it is always equal to g. Acceleration is always equal to g. Therefore, it is not having any effect. It is not having any effect. So, elevator is moving uniformly. The word is very important. Its velocity is constant. Its velocity is constant, and therefore acceleration is zero, and it is not having any effect. Whether the coin moves or not, it is not having any effect such long it is having equal acceleration, and therefore t1 should be equal to t2. Therefore t1 is to be equal to t2, right? So answer it is like that, t1 is equal to t2. Great, 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 great. Let's have another question from NEET 2013. A stone falls freely under gravity, it covers distance. So that is a stone is moving in the downward direction. So we know that A must be is equal to G. It's travel h1 distance, then it travels in the time 5 seconds, then it travels h2 distance in 5 seconds, but total become 10 seconds. Then it travel h3 distance and in the 10 second, not 10 seconds, sorry, 15 seconds, 15 seconds, 15 seconds. Don't make such mistake. 15 seconds, right? Again, let me repeat this again. A stone, here it is a stone, falls down under free gravity, that means acceleration is equal to positive g. It covers distance. First distance it is covering h1 in 5 second. The next 5 second, in the next 5 second, it is covering distance h2. Next 5 second means total time 10 second, and another 5 second it is covering distance h3. Total time is 15 second. We need to find out relation between h1, h2, h3. h1 is equal to 2, h2 is equal to 3, ht. We don't know. Some relations are given. Let's prove. Equations from God are here. So we need here this equation because we are talking about distance. Initial velocity of this is equal to 0. Therefore, we have to calculate with respect to initial velocity. We have to calculate with respect to initial velocity from this position, right? So s1 is equal to, let us consider this distance s1 with respect to original s1. So s1 is equal to, put the value, u is 0, 1 of a 10, positive time taking 5 seconds. So it is taking, this equation is first. So initially for h1 is equal to s1 for the first case, right? There is no case. Now let us find s2. It is a distance from the top, and here this is s2. So s2 is equal to u plus 1 of 80 square. Same equation. U is 0, g is 10, and taking 10 second time. So is equal to s2 is equal to 10 multiplied by 100. But see, we need here h2, right? So is equal to s2 minus h1. We need net distance. We need net distance. Putting these values, right? Putting these values, we can get h2 is equal to 1 by 2, 10, 75. Net distance. Net distance. Similar here, h3, we can give s3 from the top position s3. So s3 is equal to initial is 0, initial is 0. Then distance, it is not taking 10, but it is 15. Yeah, here it is. Sorry. It is G. 15, 225. And we need here again H3 is equal to H, or simply S3 minus S2. Put the value here and find the answer. So it become 200, 125. Now H1, if you just take ratio H1, H2, H3 like that, so it become only, this is common, here it is common, here it is common. So 25, 75, 125. If we divide everything by 25, become 135. And ultimately we can write is equal to H1, H2 by 3, H3 by 5. So like that, distance is to be covered. Distance is to be covered. And this is the ratio. This is the ratio, right? So H2 is equal to 3 times H1 and H3 is equal to 5 times H1, right? You can cross verify also by using this kind of formula. You can cross verify, right? Because velocity will increase, speed is constant. Is it so? No. Acceleration is constant, speed is increasing with time, and therefore it is to be considered. Now we have question number 13. What is mentioned here? Yeah, you pause the video and solve this question. I think already 12 questions were solved. And this question you should solve by yourself. Why not? Let's start. From a building, two balls A and B are thrown such that A is thrown vertically upward and B vertically downwards. Let's see here. Let's draw a building. This wall is sufficient. And from that, first ball is thrown vertical. Let's call ball number A with some initial velocity UA. Let's say UA, small UA. And at the same instant, another ball, it is thrown downward. Let's call B and let's call U P. And what is mentioned here? Right, with the same speed, that means UA is equal to UB. We can write U. Both are having equal speed. There is no change in the speed. Then what next? If VA and VB are their respective velocities on reaching the ground when ball strikes the ground, so this ball moves in this direction, moving downward. This is the ground, and it strikes. So for that, VA final velocity, and for ball number B, it is directly shortcut. It is taking shortcut, so it is taking VB. Right. So we need to find relation. Then question was asked in JEE. Wow. VB is greater than VA. Velocity of B is greater than V. You can assume that total travel is higher, so VA might be greater than, we don't know. Then VB is equal to VA. VA is greater than VB, or their velocities depend on their masses. Yeah. See, in this chapter, there is no mass. Therefore, this answer number D is not possible at all. So you have just three options with you. Let's have three universal equations, right? And we know that VUA initial velocity of both the balls are equal. Now, first condition, let us see the first condition when ball moves in upper direction. Balls move in upper direction. We are talking about ball number A. So therefore, its acceleration is to be considered minus G. Minus G. Right? Let's consider here. So V square minus U square is equal to 2AS. And also when there is a multi-directional problem moving from top to bottom, We have to consider upper direction as a positive, but not for acceleration, and the downward direction it is to be negative, right? So therefore, velocity is positive and the distance is negative. Therefore, you have to consider minus h for v a. So v a minus u square is equal to this equation, and then become va is equal to u square minus 2gh. This is for the first storm. This is for the first storm, right? So we got velocity of the first storm. It is like that. V square we can keep it as it is. For the second ball which is moving directly from the top, having initial velocity u and going down. Therefore, acceleration is equal to plus g. And whenever we are considering a single direction movement, at that time direction positive negative is not required. So don't go for that. Put this value here. Initial velocity is equal to g is positive, h is positive is equal to 2gh is equal to 2gh, and v is equal to vb equal to, if you see both the equations, vab is equal to vbb square. So answer is equal to vb is equal to va, right? If you don't solve it correctly, then you will definitely going to get a wrong answer, and we don't want any wrong answer. So take this. Let's have question number 14. What is mentioned? A ball is released from rest, means initial condition is given 0, from the top of the tower of height h meter. So this is the tower. Let's do a tower, having some h distance, and it is released. It is released from this point, from that, right? So release from the rest. So u is equal to 0. Initial velocity 0. It is taking t time from top to bottom. It reaches from the top to bottom t time. Great, on the ground. Now it is asked what was the height of the ball from the ground. Yeah, we have to find the ground. From the ground, what is the height from the ground? When the t is t by 3 second. If time taking is t by 3, so what is the height from the ground? That we need to find, and that was asked in JEE 2002. Great, JEE 2002. We have universal equations we already have. Put the equation and let's start. So let's have first total height s is equal to h. Time taken for the first hint, that total travel is t, right? And if it is moving from top to bottom, so acceleration is equal to plus g, direction doesn't matter, right? And what should be s? First, let us find out s, that is h at t is equal to, yeah, let's find afterward. So we know we have equation s is equal to u t divided by this equation. Let's have s is equal to h for the total travel, u 0, a positive 10, and the t is equal to t. Fine, great. So equation h is equal to 0, 1 half g t square. So let's give this equation is equal to 1, where t square is equal to 2h g. We did time, so that's why it is taken t. One equation is taken. You can keep equation in form of h also. That is also fine. Now, for the ball which is starting from top and it's just traveling, what distance? Traveling t by 3 distance is traveling, right? So we can take that h prime is height from the top, h prime height from the top. So initial speed u is equal to 0 here for this case also. So that term becomes 0. G, we know that G is positive G, and the T is taken T by 3. T is taken T by 3. Put the value here, put the value here. So H prime is equal to 1 by 18 G, 2 by H, G may cancel, right? It become H by 9. H prime by 9. H prime by 9. So H prime by 9, you have answer number A already there, but this is not a correct answer because we need distance from this position and that become H minus H prime. And therefore it become 8H by 9. 8H by 9, the answer is here, right? Right, not make such mistake. This kind of question, and whenever you make a mistake, that answer will be there in the option, so do not pick that answer. Let's have question number 15. What is asked? A balloon is rising vertically upwards. A balloon, again another question from the balloon. Why don't you solve by yourself? A balloon is vertically moving upward. Somewhere it reaches at this position at velocity. So here it is mentioned constant velocity 10 meter per second. When it is at height of 45 meter, when it is height of 45 meter from the ground, a parachutist, parachutist jump. This time it is not stone, but it is parachutist person jumps. Right, parachutist bail out from it, so he moves again. So when he move, it travel like that. It is his travel. It is not like that. Right, you are wrong if it is considered. So travel, it is going to be in this manner. So person moves in this because initial velocity of that person has to be 10 meter per second. Right. So parachute bail out from after 3 second. So it opens after 3 second. Right. And it deaccelerates at a constant speed. Deaccelerates at a constant speed 5 meter per second square. Because of it is moving in that direction. He opens parachute and moving in the downward direction. So after 3 seconds, what was the height of the parachutist above the ground? What is the height of parachutist ground? Great. Great question. Great question. Let's again read this question. A balloon is rising vertically. It reaches somewhere here at height 45 meter, and the velocity of this balloon, it is given 10 meter per second. And parachutist, yeah, it jumps like that, and he has acceleration is equal to 5 meter per second square, and the velocity, initial velocity should be 10 u is equal to 10 meter per second, right? So at what height the parachutist above the ground, at what height parachutist is above the ground, right? After 3 second, what height parachutist will be there after 3 seconds? Let's solve this. So balloon velocity is moving constantly upward 10 meter per second. So therefore, parachutist also will have the same velocity. The time required to stone hit the ground, this is not required here. So for the upward movement of the person, we know that when we calculate, so acceleration to be considered minus g. For the upward movement, upward direction is positive for the velocity and distance, and if distance is downward direction, so distance to be taken negative. Right, when the total movement is considered like that, in this case, velocity if upward then positive, and if it is going down, so distance is taken negative. Right, remember that part, right? Otherwise you will make a mistake. For that. Let's see here what is going to be that equation. We have s is equal to ut plus 1 of 80 square from the equation of God. Distance we need to travel. What distance he travel in 3 seconds? So u initial velocity is upward positive 10, 3 second, 1 half. Acceleration it is minus 10 because a person is going upward, acceleration will be negative. And after 3 seconds, we need a distance traveled by the person. So if a distance is traveled by a person, we receive a negative answer. That means when this is the parachute, it is moving, he is moving upward and he jump from here. And if it is negative, that means distance covered by the parachutist, it is negative, and that is negative 15 meter. Total distance was 45 meter. So from the ground, 45 minus 15 is equal to 30 meter. We need to take. Therefore, height of the balloon is 30 meter. Height of the balloon is 30 meter. 15 meter is not the answer. You see here, 15 meter it is there. But this is not a correct answer. You have to take this. So answer is 30 meter. So thank you very much for watching Physics Ka Doctor. This is Dr. Ghanshyam Tejani. Let's make learning a fun.